Hello again. We have understood in the last tutorial how we can move the rear and the front marker circularly over the array in order to realize the conception of circular queue. Also, we have understood how we can check the overflow and the underflow conditions for such a queue. Now in this tutorial, I'm going to write the algorithms formally, and in the next tutorial, we'll be implementing these enqueue and dequeue operations for a circular queue. So let's move ahead and write the algorithms here. First, we'll be writing the enqueue, and you can see that I have declared this rear and the front marker there. They are integers actually, and we have initialized them to size -1. Both the rear and the front are actually right now at size -1. And item is the array. Let me declare the array there. So item is an 1D array to hold the queue elements. So at the very beginning of the enqueue operation, what we need to do is to check for the overflow. If the queue is not overflow, then we need to insert the new element into the queue. Otherwise, we need to exit the enqueue. So we can check the overflow condition using this statement. If the rear +1 mod size is the front, that means if the next element to the rear is the front, then it's overflow, right? So then we are going to print queue overflow, and we will exit the enqueue operation. And you can see that we are checking the overflow condition by moving the rear circularly over the array. So mod size will actually give the value to the next element of the rear circularly. That means if the rear is on the last element, then rear +1 mod size is actually the first index of the array. And we have understood these things in the previous lecture. Okay, now if not overflow, then we need to move the rear again circularly over the array. So this time we'll be assigning this rear +1 mod size to rear in order to move the rear to the next element. And then when the rear is moved to the next element, then we can assign the value v that we intend to insert in this queue at the rear index of the array. So item rear, that's the rear index of the array, equals v. That ends the enqueue operation. Okay, now we can write the dequeue operation. So operation dequeue. We need to check for the underflow first. If the queue is empty, then we need to exit from the dequeue operation. So checking the underflow. If the rear and front both are having the same value, then the queue is underflow. Okay, so if rear equals front, then we'll print a message there, print queue underflow, and then we'll exit the dequeue operation. And if now, if not underflow, if the queue is not underflow, then what we'll do, we'll actually move the front marker to the next element. Okay, so let us just move the front to the next element. Front equals front. Again, we need to do it circularly. +1 mod size. And once we are done with moving the front to the next element, then we can just pick up the value from this front index. So v equals item front. So get the value from the front index, and we can return this value to the caller. That ends the dequeue operation. Okay, we have done writing the algorithms for both enqueue and dequeue operations for a circular queue using the circular movement of the rear and the front marker over the array. Now, I want you to try run these algorithms manually using your pen and paper. Okay, I'll give you a quiz just after this lecture, and there will be a sequence of enqueue and dequeue operations, and I want you to perform those enqueue and dequeue operations exactly as I say there in the quiz. Okay, and once you are done with the quiz, then just move ahead in the next tutorial where we are going to implement these algorithms using C programming language. Thank you, and keep watching.